Alright, in this next video I'm going to talk about problem number 83, and we don't need to go through all the definitions of differentiability again. You just need to remember that the derivative, or f prime of a, which is the derivative of the function f of x when x is equal to a, that's equal to the limit as x approaches a of f of x minus f of a over x minus a. And in order to show that that's true, then, or that that exists, since it is a limit, we have to show that the limit from the left is equal to the limit from the right. So we start off with our formula from the left. The limit as x approaches a from the left of f of x minus f of a over x minus a. Now, in this case, a is equal to 1. So the limit as x approaches 1, the limit as x approaches 1 from the left is what we're trying to find out now of that expression f of x minus f of a over x minus a. Since we're approaching 1 from the left, all of our x values will be less than or equal to 1, and so we'll use the definition in the first branch. And f of x then is just x minus 1 to the third power minus, now we want f of 1, and since we're doing f of 1, x is going to equal 1, and we get 1 minus 1 to the third power, which is just going to be 0, and that's all over the quantity x minus 1. So simplifying, we get the limit as x approaches 1 from the left of x minus 1 cubed over x minus 1, and one of the x minus 1 factors in the numerator and denominator will cancel. We get the limit as x approaches 1 from the left of x minus 1 quantity squared. From this point we just plug in, and when x is equal to 1, you have 1 minus 1 squared, which is 0. And so that is the limit of f of x minus f of a over x minus a as x approaches 1 from the left. Now we just need to do the same thing from the right. And we have the limit as x approaches a from the right of f of x minus f of a over x minus a. So we're going to have x approaching 1 from the right. And in this case, as we're approaching 1 from the right, all of our x values will be greater than 1. And so now we will be on the second branch of that piecewise function, where f of x is equal to x minus 1 quantity squared. And f of 1 is going to be 1 minus 1 squared, which we know is just 0, and that's going to all be divided by x minus 1. And simplifying that a bit, we get limit as x approaches 1 from the right of x minus 1 squared over x minus 1, and one of the x minus 1 factors in the numerator and denominator will cancel. We'll just have the limit as x approaches 1 from the right of x minus 1. We substitute x equals 1, we'll get 0 there also. And since the two limits exist and agree, the function is differentiable at x equals 1, and the derivative there is equal to 0.